So, dear pupils, welcome back to Maths with an Accent, the place where Alfredo teaches you useful maths because they are going to serve you in your day-to-day life, and useful maths because they are going to help you pass your exams. Now we are going to be tackling measuring of lengths, areas, and volumes. And this is, of course, paramount. Geometry, in fact, is built around the idea of measuring. It's built around the idea of constructing things, of building shapes, and around the idea of measuring those things in terms of length, area, and volume, concepts that we are going to be defining later on in this series of videos. Of course, if you want me to give you a practical example of the importance of measuring lengths, areas, and volumes, I can give you this example. I don't know. Let's build, or I ask you to build a cylindrical tank of 3 meters of height. Then you need to do it. And to do that, you need to purchase a plate that is going to be 3 meters high, okay? But you need to know how long do you need it to, you want it to be, or you, in order to then roll the plate and weld it. Fantastic. You need to measure things and know volumes, areas, and perimeters in order to make that. And if I add the covers of the cylinder, the circular covers up and down, you need to find out the radius of that cylinder. So I think it's quite evident the importance of measuring lengths, areas, and volumes. And in this video, we're going to tackle that. We're going to define length, find length of lines, we're going to define area and find the area of surfaces. I don't mind if those surfaces are flat, like the square, the triangle, or they are curved, like the spherical surface, like the cylindrical surface. And then if those curved surfaces are closed, we are going to find out how to calculate their volumes, the volumes they can carry. So these are the contents of this series of videos, of this pill about measurement. So now let's tackle length. What's length? Length is the number of unitary segments. Now we will see what a unitary segment is. Is the number of unitary segments I can fit, overlay, put one after the other in a given line. For instance, if we have this one, you say, okay, it's difficult to fit here those unitary straight segments. No problem. We just straighten it without stretching. We define which our unitary segment is going to be. For instance, the width of my nose, and we measure 1, 2, 3, 4, 5, I don't know, 20 noses. Or instead of noses, we could use palms, and we could say, okay, this seems to be 1 palm and a half, because it's the number of unitary segments or parts thereof I can fit on a given shape. So the idea is clear. As a nose seems something which too variable, let's say, there are different widths of noses amongst different people. We can use something more standardized. We can use centimeters. We can use the feet. And here, about this variability, I want to speak about the idea of the proportions of the human body. Since ancient times, it's known that the sizes of different parts of the body are related the ones to the other. For instance, a guy in the 1st century BC found out and wrote that the face is a tenth of the height of your height. This is an eighth. This is a sixth, and this is a fourth. Okay, this hand is over my nipples, let's say. And this guy was Vitruvius. And the works of Vitruvius were enlarged, improved by Leonardo in the 15th century AC. And that's why we have he expressed all those relationships in this fantastic and very well-known drawing, the man of Vitruvian. Vitruvian is not a place. Vitruvian makes reference to Vitruvius, the guy that first wrote down clearly all these relations we were mentioning before. So now, if you think about it, measuring lengths is in fact comparing lengths, comparing the length of some arbitrary unitary straight segment with the length of the line under study. And this unitary segment can measure in length maybe the average size of a part of the human body. I don't know, an inch width of the thumb, feet, or can be something completely arbitrary as centimeters and meters. But at least agreed upon. No, we all know what a centimeter is. We all accept what a meter is. But it can be also something completely arbitrary and even idiotic. I would say this is a truffle. A truffle it is. So it's arbitrary, but in general terms accepted amongst a group of people. So when we speak of units, of feet units, we know what we are speaking about. This, in fact, is something for physicists. Okay, they like to use different units. Here in geometry, we are going to speak of units, and we imagine some kind of unit upon which we agree, and we call it unit. That's the way we will work here. But nonetheless, you have in this slide the relations in between millimeters, centimeters, meters, decameters, etc., just for your information, let's say. So let's not digress too much. We have digressed enough, I think, with Vitruvian and speaking about units. So we know what the length of a line is. The number of unitary segments we can put one after. So unitary segments or parts thereof, I can fit and put one after the other on a given line. So with that idea in mind, we have to define what perimeter is, because we hear about lengths and we hear at times about perimeters. Perimeter is the length of a line that it's closed. So that's what perimeter is. So if we think of polygons, the perimeter of a polygon is just the sum of the length of its sides. And this applies for any polygon, triangle, polygons, regular polygons, squares, rectangles, rhomboids, etc., you name it. So from that point of view, when the segments defining the shape are straight, it's easy. But when it's curved, it's not so easy. Conceptually, yes, it is. It's just a matter of straightening. But if we think, for instance, of a circle of a given diameter, what we want to know is what's the perimeter of the circle expressed in terms of its radius or its diameter. We don't want to build the circumference and then unroll it, let's say, and measure. We don't want to do that. We want to actually know some kind of formula telling us what's the perimeter of the circle, what's the circumference in terms of its radius or its diameter. And this is not so evident. Let's tackle together this very interesting problem, which is going to introduce, as some of you are suspecting, the number pi.